Last lesson for this unit is on composite figures. So looking at what you have in front of you, can you give me an idea of what a composite figure is? It's multiple figures combined together. Okay, so if I'm asking you to find the volume of composite figures, we're going to have to find the volume of each and then either add or subtract depending on what our figure looks like. So looking at number 1, what do you think you notice about this figure? Oh, okay, so you see a cylinder. So we'll start there. We see a cylinder. And we see a rectangular prism, right? Okay. Everyone agree that they see a cylinder and a rectangular prism? Perfect. So let's start by finding the volume of each. Okay. Let's start with the prism first because it is a cube, you're right, because all the sides are the same. So let's find the volume of that cube. Which formula do I use for a prism? Length times width times height, okay? My length is 8, my width is 8, and my height is 8. Eight times 8 times 8. This is where you're 512. Okay. So far, so good? We also see a cylinder. What is my formula for volume of a cylinder? Pi r squared, because it's the base area, times the height. Now, do you know what the radius is? Do you know what the diameter is? Yeah, what's the diameter? 8. Because this distance all the way across is the same as this distance, which means my radius is 4. So pi times 4 squared times my height, which is, how tall is the cylinder? 8. Okay, what's 4 squared times 8? 128. So I have 128 pi. Now let's think about this for a second. Okay, so we have the volumes of both of them. Now specifically, what do you notice about this figure? What does it look like to you? Like if you were to describe it in real life, what does it look like? A box with a can inside, okay. Anything else? Does it kind of look like a tunnel almost, like you could go through it? Right? So the cylinder is inside the box. Do you think that I'm going to have both of the volumes and I'm going to add them together? No, they're already one, right? And I think it says... Okay, so because it's a cylinder and you can technically walk through it, I'm taking out the volume of the cylinder from the prism. So I need to subtract these two. Now, can you subtract 512 and 128 pi? No. First thing you need to do is you need to convert 128 pi to a decimal to the nearest tenth. What do you get when you convert that to the nearest tenth? 402.1. Okay, so I'm taking my prism, which is 512, and I'm removing that cylinder, because I need to take that cylinder out, 402.1, and you get 109.9 feet cubed. 109.9 feet cubed. So we had our prism and we took the cylinder out of it. So we have to subtract the two. Are you okay with that? Yeah? Sure, maybe. All right, let's try another one. Okay, so what figures do you see in this second one? You see a prism and another cylinder. Now, do you notice how I'm organizing my information? I'm actually writing out what I see so that I can solve, and then I figure out if I need to add or subtract. So let's find the volume of the prism. Length times width times height. What is the length times the width times the height? What are the numbers I'm going to use? So what's my length and width?
4 and 8.
4 and 8. And my height? 5. 4 times 8 times 5. You should get 160. Okay. Now if I'm looking for the cylinder is pi r squared times the height. What's my radius? 1. What's the height of the cylinder? 2. So 1 squared is 1 times 2 is 2, so that's 2 pi. Now, what do you notice about these two figures? They're really just attached to each other, right? We have the prism, and then we have the cylinder right next to it. So, am I removing anything? No, I'm going to add them together. Now, my question to you is, can I add 160 and 2 pi? No. So, what is 2 pi rounded to the nearest tenth? 6.3. So 160 plus 6.3, because they're just attached to each other. We're not taking anything out, so we're adding them. So you get 166.3 centimeters cubed. Okay. I want you in your group to try number 3. So figure out what your figures are, and find the volume, and then decide if you have to add or subtract. What do we see in number 3? You see 2 cones, right? We have a small one, just so I can differentiate, and we have a large one. Agreed? That's an N. I promise. I just scribbled. I know it looks like an N. It says cone. Okay. So, the small cone. What is the formula for a cone? 1/3 pi r squared times the height of the whole thing. So, looking at the small cone, 1/3 pi, what's my radius? 6. What's the height of the cone? 10. Okay, so 6 squared so 6 squared is 36, times 10 is 360, divided by 3, what'd you get? 120 pi, right? The large cone uses the exact same formula, except what is my radius now? 10. And my height is 26. Okay, that I can't do in my head. What did she, What's wrong? So 6 times 6 is 36. Times 10 is 360. Divided by 3 is 120. 10 squared is 100. Times 26 is 2600. Divided by 3. 866.7. Did anyone else get that? Okay. Now, looking at these 2 cones, am I going to add or subtract them? Add them. You're just attaching them to each other. Can I add them together as is? Yeah, you can, because they both have pi's. So if you converted to the nearest tenth, that's fine. If not, you can just add them together. But you are adding. What was your final answer? One person tell me, and loudly. Go ahead. Just go ahead, yeah. Tell me what you got.
Wait, is this just like not rounded to figures?
Yeah, you can just do it and keep it in terms of pi. Yeah, you're right. Okay, so 986.7 pi meters cubed. So you can leave that one in terms of pi. If you want to round, that's fine. Make sure on your test you read what the directions ask you for. Okay, so if they both have pi in their answer, you can add them together. If they don't, you have to round before you add or subtract. If you round to the nearest tenth, let me grab my calculator. If you round to the nearest tenth, you are going to get 866. You're going to get 3,099.8. Yeah. Okay, so if it's rounded to the nearest tenth, you'll get 3,099.8 meters cubed. So here's in terms of pi, here's rounded to the nearest tenth. Okay, either one is correct. The difference is you need to make sure you know what the directions are asking. Okay, either one is fine. Are we okay with that? Okay, last problem. What do you see here? I see two pyramids, and did you say something else? A prism. Okay, so we have a prism. We have a larger pyramid, and we have a smaller pyramid. Okay, so the prism is this bottom piece that it's sitting on. Volume of a prism, length times width times height. What is the length and the width of that prism? 9 and 18, and the height? 2. Okay, so 9 times 18 times 2 is 324. Okay, that's the volume of my prism. What's the formula for a rectangular pyramid? 1/3 length times width times height. Now let's look at the large pyramid first. So what is the length and the width of this base? 9 and 9. It's 9 here, and it's 9 here. Backwards, the back distance is 9. Do you see that? Okay, so that should be 9 and 9, and what's the height of the whole thing? 18. So 9 times 9 times 18 divided by 3, 486. Okay, same formula for the smaller one. Let me move that up so you can see better. Same formula for the smaller one. 1/3 length times width times height. Now, if I'm looking here, what's this distance? 9? How'd you get 9? The whole thing's 18. This piece happens to be 9, so that piece is also 9. Okay? So 1/3, 9 times 9, and what's the height of the whole thing? 16. So 9 times 9 times 16 divided by 3 gives you what? 432. And what's happening with all of these? What are we doing with all the different figures? We're adding them because they're all just stacked on top, right? So 132 plus 486 plus 432. I think I said 132. I meant 324. I said the wrong thing. So 324 plus 486 plus 432. What do you get? 1,242 feet cubed. So composite figures is everything you've done. You just have multiple figures together. Any questions on that? No? Okay.